The M4 Mac Mini has been one of Apple's best hardware releases in recent memory, mostly due to the highly optimized ARM CPU, the small footprint, and the insane affordability. And this was before that little thing called AI got popular. With the sudden craze of OpenClaw, the M4 Mac Mini became one of the most sought-after devices seemingly overnight. Well, I've already tested the M4 Mac Mini as a home server and even ran some AI workloads on it with surprising results. But what if we take it a step further? Because if one Mac Mini is great, then two must be better. And if two is great, then three must be better than that. And if three is great, then I'm kidding. I only have three. The idea is that I want to create a Mac Mini cluster to see if the whole is actually greater than the sum of the parts. So let me actually set this up in my cute little 3D printed cluster thingy. Beautiful. Now, I'm sure you've seen quite a few videos on people making clusters out of Macs, most recently the Mac Studio. This is because the Mac Studios and even some of the Mac Minis have a little trick up their sleeve called RDMA, which essentially lets each of them talk to each other super fast over a Thunderbolt connection. Well, the M4 Mac Mini doesn't have that, but they do have regular old Thunderbolt 4, which I'm thinking should be good enough. You see, when running AI workloads on a single machine, the entire model is contained to that single device. Duh. But when you're clustering and the inference for the model is spread across different devices, then you need to make sure that they can talk to each other as fast as possible, or you're going to be severely bottlenecked. I mean, we're still going to be bottlenecked by Thunderbolt 4, but how much? Well, we're going to have to see. So of course we are here at Micro Center, which is honestly one of the best places where you can come and check to see if there are any Mac Minis in stock, because like we discussed, they're a hot commodity right now. So come check out Micro Center, not just because they're sponsoring this video, it's because we love Micro Center, right? We love Micro Center. So why is the Mac Mini so good for AI? Why is everyone flocking to get these for their OpenClaw instance? Well, it's simply because of their unified memory. But what is unified memory? Well, in all of Apple's chips, the RAM is pretty much built into the CPU, so they can talk to each other super fast, all in one chip, unified. The reason this is so beneficial is because when you run AI models, they're all stored directly in the memory. So if the memory can talk to the CPU and GPU super fast, then great, your model's gonna run better. Now what Apple has done here with the Mac Mini is they've come in at a super affordable price. So $600 for any system with unified memory is crazy, and that's why people love them. They're super cost effective. So the one we're going with here is the baseline model. For $600, you get the M4 Mac Mini with 16 gigabytes of unified memory. And what you also get is Thunderbolt 4, which we will use to cluster these. Now, this isn't your only option, obviously. The Mac Mini also comes in other flavors, like the M4 Pro version, which gives you even more unified memory, and Thunderbolt 5 with RDMA. And also, its big brother over here with the Mac Studio. So with the Mac Studio, you also get even more memory, faster CPU and GPU, and Thunderbolt 5 and RDMA. So obviously it's going to cost more, but you're going to get better performance. But for us, what we want to do is we want to see if we go with the most affordable Mac Mini, is this viable as a cluster? So only one way to find out. So in terms of hardware, you really don't need much. The Macs will each just be set up like they would any other Mac, but we're just going to connect each of them to each other via a Thunderbolt cable. So the connection kind of looks like a triangle, and that's it. That's the hardware setup. Now we actually get to jump into the software and start by configuring the Thunderbolt bridge on each device. We have to go into the network settings, create the Thunderbolt bridge, and assign it a static IP. What's cool about macOS is how easy they make it to bridge these connections rather than having to have separate IPs per Thunderbolt connection. Because you see, we have 2 per Mac Mini. Once you do that on each device, ensuring that they're in the same subnet, you should be in a spot where they can talk to each other. Neat. The software we're going to use for our cluster to function as an actual single entity rather than 3 individual nodes is a program called Exo. I'd say it's pretty much the go-to right now for Mac OS clustering, since it gives you solid, optimal clustering performance with Apple's native MLX. It's got a clean UI and it's super easy to set up. You legit just install it on each machine and it automatically finds your other nodes on the same network and will default to use any Thunderbolt network. It's actually comically easy. So here we are loaded up in the UI. After everything is connected to each other, it spins up its own web UI. You don't have to do literally anything else except navigate to one of the IP addresses of one of your nodes and the port that it runs on, which is 52.4.15. So the first thing you'll notice is the layout of your machines listed here, and you can see it represented by the actual physical connections we have, which is a triangle, meaning that each node can talk directly to the other in a triangle configuration. Makes sense. This is a triangle. The other thing you'll notice up here at the top left is RDMA is not enabled, which makes sense because we don't have RDMA on the M4 chips, but we do have it on the M4 Pros and the Mac Studio. So if you have that and you have it enabled, it will automatically use RDMA. Again, no configurations needed from the user. XO, like I said before, is just comically easy to set up and use. So to get started actually using it, you'll come over here into load model. When you click that, it'll recommend some models for you that will fit in your setup, which is extremely nice. You don't have to go through the zillion different models and decide which one or which ones can fit in your setup. This will tell you right here. It's nice. So you see the popular ones here, Qwen 3.5, 3.4, GLM 4.7, Gemma. NVIDIA has their own. So they have the Nemotron Nano, Llama model. And yeah, those are the big boys. Or you can just browse Hugging Face and download whatever ones you want. But yeah, let's pick one out here. And I think I've already downloaded Qwen 3.59B. So for 9B, you can see here, we can actually use either the 4-bit or the 8-bit quantization. I believe if you come over here into downloads, you'll see which ones have actually been downloaded to each node, which is extremely convenient. So you can see we actually already have the Qwen 3.59B, 8-bit and 4-bit on all of our nodes. Now with each node, I think it's really cool how they show you the important statistics for each one. So utilization, temperature, and power of each, along with how much VRAM you have available and how much you're using on each. And that's what is going to fill up this little yellow bar here. And when you load in a model, you can launch different instances of it. So over here, you'll see that model on one node. Do you want to run it on 2 nodes, or do you want to run it on all 3? So since this is a 10 gigabyte model, you can run it on just one. So if we launch it on just a single node, it'll load that up and it's ready to chat. Just like that, you can start talking to it. And you can tell over here, it is running on this node since based on the bar, it's loaded up a bit more than the others. Let's do a Relly chicken dish. And it's going to start giving me a recipe. So just a generic chatbot. You guys have used a chatbot before, I assume, in the year 2026 at this point. So yeah, you get it. And down here, it'll give you the stats. So here you can see we're hitting 21 tokens per second, which is about what you'd expect on a single Mac Mini. Now what we can do is load in a larger model. So Qwen 3.5, 27B, 8-bit. And since it is such a large model, we only have one option, and that is to run it on every single node. Ready to chat, and you can see we are using pretty much all of our VRAM here, 14.2 out of 16, 14 out of 16, 14.1 out of 16. So this is probably the biggest model we can run. And let's try the same thing. And you can see it's a bit slower, obviously. And we'll certainly talk about that. But one other cool feature in XO is the integrations. So if you go over here, there are integrations for all your favorite UIs for using AI, and along with the URL endpoints for common APIs. So Ollama, Claude, and OpenAI. So the cool thing about this is that we can run something like OpenWebUI, and it'll use that Ollama endpoint to talk to this entire cluster as it would a just singular node. I think it's running on my MacBook. Cut to me using OpenWebUI with this cluster. And yeah, it's pretty cool. You can legitimately treat this as you would just a single node, except that it's a cluster of multiple nodes. Really awesome, really cool software. I'm honestly amazed at how simple it is to use. So right away, let's talk about when we ran our pretty standard consumer model Qwen 3.5 9BQ4. Running that on a single M4 Mac Mini got us 21 tokens per second, which is pretty respectable. I'd say if you're between 20 and 30 tokens per second, that's roughly your sweet spot. Any lower and it starts to feel slow, and any higher and you're thinking about upping your quantization. Now, what happens if we run that same model across two Mac Minis? Wait, 19 tokens per second, that's lower. Yes, and that is expected. I mentioned earlier that we'd have Thunderbolt bottlenecks here, and that's what we are seeing. AI models are extremely dependent on memory bandwidth, so when that bandwidth is cut down to the speed of Thunderbolt 4, you're just going to see a drop in performance. There's no way around it. That combined with regular old TCP network overhead and Thunderbolt overhead, yeah. And if we add another M4 Mac Mini, we still get 19 tokens per second, so clearly that Thunderbolt 4 connection is our physical limitation. But that's not entirely a bad thing, because while our decode speed may have dropped, our memory pool got 3 times larger, meaning we can run some larger models. And you saw when I loaded up probably the largest model I can get on here, Qwen 3.5 27BQ8, so a pretty solid consumer model. This required all 3 Mac Minis just to run, and we were getting a whopping 3.7 tokens per second. Yeah. Obviously, that's not going to knock your socks off, and you wouldn't use this for any real-time AI tasks like a chatbot, but you could use it for automated agents that run in the background. If you have some processes that run overnight to check code changes or do some kind of forecasting, it may not matter if the process takes 5 minutes or an hour, and that larger, more accurate model may be worth the slower speed. So let's talk alternatives, because we mentioned before that there's an M4 Pro Mac Mini with Thunderbolt 5 and RDMA, as well as the M3 Ultra and M5 Max Mac Studios. I don't know why that's so hard to say. I gathered some benchmark numbers of those same models on these units, and one thing you'll notice is that they're faster. Duh. But what you also may have noticed is that when you add more M4 Pros for our larger model, the decode gets faster. Why? Well, that's because of the magic of Thunderbolt 5 and RDMA. Mostly RDMA, which essentially lets your device's memory talk directly to each other without the typical network overhead. In a program like EXO that's heavily optimized to use RDMA, that's a big deal. So let's break all of this down into some takeaways. I think we need to find out what the best setup is, and that's going to be dependent on a few things: your use case, your budget, and your need for simplicity. Let's start with what I think is the category that most people fall into. You want to run local AI for things like OpenClaw and some casual tinkering. Even with the lower speeds, I think the base M4 Mac Mini takes it here. With 16 gigabytes of memory, it can run your standard, smaller consumer models and do so at a crazy affordable price while sipping like no power. I also like the base Mini for those just looking to expand their memory pool while already having a Mac Mini laying around. Now, what about those who are a bit more tech savvy and have a bit more dialed in use case for AI and know they'll be running some larger models? I think you have to go with the M4 Pro Mac Mini here. While it does cost more, it's still less than the Studios, and you can even get it with up to 64 gigabytes of unified memory. You also get the Thunderbolt 5 with RDMA for future expandability, so you can not only scale your memory pool, but also your decode speed for larger models. And I think you see where this is going, right? What if you're a professional with very demanding AI needs? Well, it basically comes down to the M3 Ultra or the M5 Max Mac Studio. Or do you wait for the possible M5 Ultra Mac Studio? Yeah, I won't speculate on that, but between those two, I'd say if you're running high-end consumer models like anything around 70B with 8-bit quantization, the M5 Max will be your winner. But when you get into larger, more dense models, the higher memory bandwidth on the M3 Ultra is going to take over, so it really just depends on the models you're going to run, which I think you should probably know if you're looking to drop like $10,000 on a computer. But yeah, that is all I have for this one. Let me know what you think down in the comments. Are you running a cluster of Mac Minis, or are you just rocking a single one? If you like this video, then drop a like and subscribe, because I may have another AI cluster video coming out very soon. I want to give a huge shout out to my YouTube members and my Patreons. You guys are my AI cluster that gets like a zillion tokens per second and uses like 10 watts of power. Y'all are efficient. And if you're still watching, you're USB 3.2 Gen 2. Thank you so much, and I'll see you in next one.